Okay, morning everyone. Okay, so moving on to Earth internal temperature. Okay, as you already know, this is the Earth. Okay, the crust. So this is the crust. As you go deeper, the temperature is actually increasing and increasing and increasing. Okay. So in here you can see solid but slowly deform in plastic manner. Then this is molten, and basically even for steels we can just burn up to 2,800 degrees and it's like really hot. Then you can see that in the middle is about 4,300 degrees, so it is very hot. Okay, so this is the come to the part where you have the condition where the Earth internal is hot. Okay, so this part is off and the Earth moves slowly upwards towards the cool surface, and the rock that is deep within the Earth and is very hot rise slowly towards the surface, while the rock that is cool near the surface is dense, then it sinks downwards. This cycles is what we call a mantle convection. So mantle convection is the movement of hot and cold of this mantle. As you can see in here, this happen underneath this crust layer. Okay, so this is the crust layer. It's happened underneath the crust layer. So some materials, okay, when it's cold, then it might change to rock. So it might change to rock. That material actually going to join together with this crust and form to create this crust. Then later it will sing again. Then this happened in the form of kind of slowly, but constantly process, okay, underneath the earth. So every time when this happen, okay, just imagine that when you have this plate, okay, this is the crust, okay, so underneath you have this cycle of magma convections, okay. So when this cycle of magma convection, what happens then? It is in a very hot materials, and when it's very hot materials, basic thermodynamics, you have a high amount of pressure, right? So when you have a high amount of pressure, every time it goes up, it's going to have a energy. As you already know, energy cannot be destroyed, cannot be created, it can be transferred. So every time when you have a very high energy, that energy going to transfer to another medium, and that medium is this one, the plates, okay, the plate, the crust. So every time when you have things happen, you have the plate movement that going to affect, is going to create continental, ridge, mountain, geological structure, and at the same time, it's also going to create earthquake and volcano. Okay, so the moment that you have this one, if you have a ridge, this is what you have. This is what we call the ridge. Okay, if it's happened in the ocean, you have a mid-oceanic ridge. Okay, and you have an upwelling of magma. So upwelling of magma is actually the magma going to go upwards. Okay, when they go upwards, and all the magma they're going to rise in here. And because of the change of the temperature, so imagine that within this layer is about 1,000. Initially, you have 4,300 degrees Celsius. Then later, when you go to here, you about 1,000. The moment when you reach here, you have about like 0. So when you have that sudden change, okay, that sudden change of temperature, material they're going to harden. Okay, once the material harden, then that is actually creates the geological features of one particular area. Okay, so if it's in the land, then you can get ridge, you can get mountains, you can get other things. If it's in the ocean, you have mid-oceanic ridge plates. You have many plates. You have Antarctic plates. You have Australian plates. You have Indian plates. You have frequency, Eurasian, Arabic plates, African plate, South American plate, Nazca plate. You have Pacific plates, North American plates. Okay, so we call it a plate because we consider that within this huge body of Earth crust, okay, this is like one huge plate. Then when you have a different plates, okay, when you have a huge body of Earth crust, okay, then that body we're going to call on a different plates. Okay, so based on the regions, then you have that in the different plates. Then as you can see in here, Malaysia is actually at middle of that plate. Okay, so when Malaysia is actually at middle of that plate, so that's why we do not have much of a geological disaster like those earthquake or even volcano. Okay, so within these plates, every time when you have a one plate and another movements, okay, and that movement actually going to have effects on geological conditions. Okay, so this is three types of margin, or three types of, they call margin, but this is actually three types of movements. Okay, movement of the plates. So you have diverge, you have converge, you have transform. Okay, so this is the margin. Then the motion is diverge, is spreading. So you can see it's underneath here. It's actually spread. So it's spread. So die is basically two, right? So one is actually become two. So it's diverge. So spreading. Converge. This is actually going to converge. So initially you have two, now you are going to subductions. Okay. In subduction, basically it's like a diving. Okay. So they're going to dive, subductions. So when they dive, they're going to reduce. And transform basically is lateral sliding. So you have, it's just two materials that's slide between one another. Okay, so in the diverge, basically it's constructive. So you can oceanic lithography, lithosphere is created. Okay, topography is rich as well as reef. And volcanic activity, yes, you have volcanic activity. Why? Because as you see in the previous mantle convections, you have magma upwelling, right? Okay, so that is diverge. And you have second one, converge. Okay, converge is a subduction. Subduction is the most common conditions that we have around the Earth, and it is kind of a condition where you have a lots of geological activity that you need to consider, especially when we deal with any construction works. Okay, because as you can see in here, in subduction, you not just deal with volcano, but you also deal with earthquake. In here, okay, earthquake happen because you have, like in here, you have one material, one plate, then you have another plate. This plate is going go downward of that plate. So if you have your building in here, So you just imagine that every time when this constantly happens, you're going to have the vibrations due to the energy transfer of the subductions, then you're going to have earthquakes. So your structure, your bridge, your roads, or your buildings, even landfill, must be consider being able to take that amount of loads from the earthquakes. Okay, so that is things that in civil engineering need to consider. Okay, so the third one is transform. Transform is basically lateral slidings. Okay, this is conservative. There's no major effect in the topography. Basically, it's just like it won't create any geological features like converge. You're going to create a trench, okay, and there is no volcanic activity, but you have the earthquake because it's actually when the moments it moves, you have that vibrations, you have that frictions, and that friction actually going to transmit on off loads. Okay, so that load is actually going to create a volcano. Earthquakes. Okay, so as you can see in here, this is plates. Okay, we have lots of plates around the world in the earth. And this arrow show the type of motions. Okay, for this, as I can show, we have spreading. So spreading, can you see the arrow? Okay, so you have lots of plates in here. Okay, so as you can see, this is the plate movements. Okay, and subduction zones. You have laterals. You have the diverge. Okay, so you have converge, you have diverge, and you have lateral movements. Okay, so in the subduction zones, okay, this is one example. So usually, it's not usually, it is the plate that is much higher in terms of density. That plate is the one that going to going downwards. Why? Because it's heavy. Okay, so this one, the top one is basically the one that is much lighter. So this one, the one that going to go subduct, is actually the one that is heavy. So if you put into a perspective of continental plate and oceanic plates, you can see that oceanic plates is just 5 kilometers. Oceanic continental is about 30 kilometers. So although it's 5 kilometers, it is actually very, very dense because it's already like compact. So when it's very dense, it's very heavy. So when it's very heavy, it's going to go downwards. So as it goes downwards, this material, you have lots of huge energy. So when you have huge energy, there where you have a friction, and at the same time, it's increased heat. So when it's increased heat, then all of these materials or the rocks or the plates will start to melt. So when it start to melt, it starts going to fill up all this volcano. So when it's filled up all this volcano until a certain period of time, then it will erupt. And in oceanic trench, okay, so it's the same scenario. So the moment that when it's going down, then it's also going to create oceanic trench. Okay, so trench is basically when you have a condition or place that is very deep, okay, but the width is very, very small, like you dig a trench. Okay, I believe we learned this in geography last time. You have lots of oceanic trench, right? And the deepest one is where? This one, right? Mariana, okay? It's about 11 kilometer. So within this 11 kilometer, you just imagine that in a very narrow space area or within this seabed floor, then you have a very, very deep, 11 kilometer of space. Like if you are there, you're going to see like 11 kilometer of wall. Okay, but it's definitely is like very, very dark. In the very deep sea area, in even for human, it is very difficult for you to go to very deep because of the pressure, right? You have a pressure from water similar to what you have in the soil, in the rock. As I mentioned, as you go deeper, you're going to have an increased pressure because of the overburden loads from on top of it. Okay, so as you go deeper, of course, the pressure going to increase. Okay, so in deep oceanic trench, so it looks like something like this. So it's like very narrow. Okay, so when the area is very narrow, but it is very, very deep. Okay, so you have this is example of Puerto Rico trench. Then you have any other trench. So this is ring of fire. So in the ring of fire, I believe you already heard this thing before. You have lots of because it is in the boundary area, right? So when it's in the boundary area, basically you will have lots of geological event that's constantly occur until the end of Earth. Okay, so in that case, meaning that you constantly going to have earthquake, you're going constantly to have and magma upwelling. So when you have a magma upwelling, and at the same time you're going to have a volcano. Okay, if it's happened in the sea area, then basically you're going to create a oceanic ridge, right? Then if it's happened in the land, so that's why you have some volcano in this in Indonesia, you have volcano in Japan, you have volcano in many other countries. Okay, in the South America, and so this is because of the boundary. So when things happen in the boundary, so imagine that magma is something like it's liquid, right? So when it's liquid, if you put something in the plates, okay, when you put something in the plates, there is no crack within that plates. The water can actually hold throughout the plates, even if you bring it anywhere, right? So that is what happened in the earth. Yeah. So if it's in the middle, so you will not have any water going down or penetrates. So you will not have that leak. But the moment that at the edge, okay, so similar case in here, if it's at boundary, you have that opening. Okay, so when you have that opening, there is actually the place where the magma can start to infiltrate. Okay, so basically they're going to move from high pressure to the lower pressure. So it is very difficult for the magma or even for water itself, okay, to move into an area that they need a higher pressure, right? Because they have like that plates that actually covers or obstruct their path. But if it's have a boundary, it has opening, it's porous, so that is where the magma or any liquids can start flows. Okay. Okay, so as you can see, landform. Okay, so if you have continental versus continental, if you have two continental, okay, if you have two continental that's collide, because these two continental is have less density. Okay, continental is less density compared to oceanics. So when these two plates collide, what usually they're going to create a mountains. Okay, so when they collide, they're going to create mountains. And in oceanics, okay, in the previous example, in the subduction, usually you have one continental and another one is oceanics. So usually it's like one one low density, another one is high density. Okay. So in the case that when you have both is oceanic and oceanic, so you have a high density, right? So when it's high density, it's heavy. So when it's heavy, basically it's going to go downwards. Then it's going to making a the oceanic trench. Okay, on this part, can you understand? Everyone, okay? So you have continental, and continental is light, so it's going to go upwards. When oceanic and oceanic is going to go downwards because it's have a high density. So this is the theory of continental drift. Okay, in the continental drift, um, it is said that India basically separate from the mainland. Okay, separate from the mainland. Then after million years and million years and after million years, it's actually moving. Before we finish our class for today, any questions? Any questions? Okay, if not, then thank you very much, guys.